This section is really short. It's talking about direct and inverse variation. So we will solve direct and inverse variation problems. For a direct variation, general form is going to be y equals k times x to some power. And they'll tell us if it varies directly with the third power of x or the squared power of x. So it's going to tell us what power is going to go on x. And we're going to be able to write this equation and be able to solve for k so that we can create our general direct variation equation. The first problem wants us to solve a direct variation problem. It says the quantity y varies directly as x. If y is 45 when x is 5, find y when x is 13. So we need to remember that y is equal to k times x to some power. So the first thing we're going to do is create our equation based on the power that it tells us. It just says directly as x, meaning that the power is 1. There is no power on x. So y equals kx is going to be our equation. Next, we're going to use our first pair of values to plug in for x and y to solve for k. So that means 45 equals k times 5. And if we want to get k by itself, we're going to divide by 5. So 9 is k. We're then going to put that into our form and actually get our equation for this relationship. So y is equal to 9 times x. That is the relationship for this pattern. Then we can make our prediction or find y when x equals 13. So find y when x is 13. So plug in 13. Well, 9 times 13 is going to give me 117. Next one says the quantity of y varies directly as the square of x. If y equals 64 when x equals 2, find y when x is 5.5. So we're going to start with our equation. So remembering that y equals kx to a power. So for us, this is y equals k. X is the square now, so x is going to be squared. Step 2, we're going to plug in our given x and y to find k. So 64 equals k times 2 squared. 64 equals k times 4, so then we're going to divide by 4 and get k equals 16. That means our equation for this relationship is y equals 16x squared. And if I want to now find y when x is 5.5, I'm just going to plug in 5.5 squared. I'm going to times that value by 16, and I will get 484. The other type of relationship we have is called an inverse variation. And this one is going to be y equals k over x to a power. So now we have y varies inversely with some power of k. We will follow the same process to create our equation, find k, and then solve for the missing variable. The quantity y varies inversely as x. If y equals 6 when x equals 3, find y when x equals 9. So you need to remember that the general form is y equals k over x to a power. So for our specific problem, it just says y varies inversely as x. So there's no power on x. So y equals k over x is our equation. We're going to use our given x and y to solve for k. So 6 equals k divided by 3. Well, if I'm dividing by 3, I'm going to times both sides by 3 and get 18 equals k. That means my given equation for this relationship is y equals 18 divided by x. So if I want to find y when x equals 9, I'm just going to plug in 9 for x. So y equals 18 divided by 9, or 2. The quantity y varies inversely as x. If y equals 12 when x equals 8, find y when x is 16. Again, it's k over x to a power. Our x does not have a power here, so it's just k over x. Plugging in our y is 12. We don't know k, but x is 8. So to get k by itself, I'm going to times both sides by 8. And I'm going to get 96 equals k. So our given equation for this relationship is y equals 96 over x. So if I want to find y when x is 16, I'm just going to plug in 16 for x. That takes 96 divided by 16 and gives us 6. That is the end of this section. Told you it was short. Go ahead and do your homework. And next up is going to be a quiz.